let's look at a couple important vocabulary terms that we want to understand when we are factoring here and using the distributive property and taking out greatest common factors and things like that. Okay, so the first one we want to understand here is prime. Okay, so a polynomial is prime. Let's even write that. Let's say a polynomial is prime if it is not the product of polynomials having integer coefficients. Okay, so I know this is kind of confusing definition, right? So I'm going to explain it just a little bit more. Okay, again, a polynomial is prime if it is not the product of polynomials having integer coefficients. So let's just consider this. I'm going to consider 3x squared minus 5. Okay, and I'm going to kind of scan this thing over. Okay, I'm going to write this as an example. Okay, so I'm going to scan this thing over and I'm going to see, okay, well, 3 and 5, right? What's the greatest common factor between 3 and 5? Okay, and so I'd say, all right, well, 3, I have, 1 times 3, and there's no other factors here. In fact, 3 is a prime number, and 5 here, I can, 1 times 5, and there's really no other factors I have of 5. Like 2 times nothing is going to give me 5. 3 times nothing will give me 5. Okay, we're just working with integers here, remember? So I can't really take anything out. And honestly, like, this first term I have an x squared, and the second one is a constant. I don't even have an x there, so there aren't any even any x's in common, right? So I can't write 3x squared minus 5 as the product of two other polynomials that have integer coefficients. Therefore, I would say that this is prime, right? I can't factor this out anymore. It's just prime. Okay. Now the second part that we want to understand here is kind of the directions when they ask us to factor a polynomial completely. Okay, and that's just going to be writing a polynomial as a product of, and I'm going to write monomials, as a product of monomials, or prime factors with at least 2 terms. Okay, so remember, just a monomial could maybe even be something such as like the number 5. Okay, and prime factors with at least 2 terms. That would mean, it could be like a binomial, right? So maybe it's something like 2x plus 4. Okay, and so again, factoring a polynomial completely is to break it down as much as possible, like we're taking out as many factors as we can using the distributive property. Okay, so again, this is just a little bit of terminology that we really want to understand to make sure that we can move forward appropriately. Okay, so let's look at this. So let's try to recognize which one of these is complete factorization. Okay, so it says, tell whether the polynomial is factored completely. Okay, so in part A, it looks like what they did here is they said, well, there's a 2 and an 8 they can take out here, so we could take out a 2 and maybe write this as divide by 2, and then what's left over here is going to be x squared plus 4, right? And now we want to see if x squared plus 4 can actually be factored. Okay, so remember, in x squared plus 4, in this part we're looking at right here, our a term is actually just 1, and our b term is 0 because there's no x term, and our c is 4. So can we think of any numbers that multiply to a times c or multiply to 4 but add to 0? Okay, 2 numbers that multiply to 4 but add to 0. I can't think of any. Okay, again, 2 times 2 would add to 4 and multiply to 4. 1 times 4 would add to 5 so we can't. Okay, so I would say in this particular answer that yes, this particular polynomial is factored completely. They did a good job with this part. There's no more that they can actually take out. That's a monomial and a binomial factor here, and we can't break this down anymore. Okay, so let's look at the next one. Okay, so now we have 2x squared minus 8. So it looks like what they did is they said, well, we have a greatest common factor of 2 here, and they divided by 2 on each of these, and they're left over with now x squared minus 4. Okay, well now, in this particular example, we'll look at this part again, and we realize that our a term here is 1, and our b term is 0, and our c term is now negative 4. And so we ask ourselves, well, can we think of any numbers that multiply to a times c, or multiply to negative 4 but add to 0? And yeah, actually we can, right? 2 and negative 2 would work in this case. Okay, and so we would say that, well, this can be written as actually 2 multiplied by x plus 2 and x minus 2. Okay, and now this is considered complete factorization, right? So I guess if we would say no for this example, right? Because we can actually factor this further, right? It's a monomial multiplied by a binomial multiplied by another binomial. Okay, so we just have to sort of understand, we're trying to factor out these things as much as possible to factor them completely until we have, maybe a monomial factor and some binomial factors or even more.